units, even this trimester and last trimester. Okay, so the last thing is we want to be able to decide. We want to be able to decide if something is linear, quadratic, or exponential, so that we know what we need to be doing in terms of the graph, and or making a table, and or whatever. Okay, this one is pretty straightforward. So if we want to decide if something is linear, quadratic, or exponential, there are a few basic pieces that we can recognize. Okay, if something is linear, to know that something is linear, we know a couple things to be true about them. Okay, the graph is always going to be a line. So if you see a graph that is a line, you know that that is a linear function. Okay. If it is an equation, when we know it, we'll be able to go into the form y equals mx plus b. Now, you might have to solve it for y to get here. So the key is that the x and y have no exponent, which they really do have an exponent. What's the exponent on the x?
1.
1, we just don't see it. Okay, and if it is a word problem, it'll have something that is a constant change. Every month, you will make an additional $10. How much do you make extra after the first month? $10. How much do you make extra after the second month? An extra $10. How much do you make extra after the third month? $30. An extra $10, right? That's never going to change. It's always an extra $10. Okay, that means that it is linear. Something that costs $4 per flower. Well, it doesn't matter whether it's your first flower or your 10th flower, it's going to cost $4. That is linear. Okay, if something is quadratic, what does a quadratic graph look like? Do you remember? That's the U, that's our parabola. Okay, it's going to be a parabola. Okay, so if we see a graph and we know it's that shape, we know it's a parabola.
Parabola.
Likewise, if we know it's a quadratic, we know it better make a U-shaped graph. Do you remember what quadratic graphs always have?
Quadratics.
They have an exponent of 2. Okay, so realistically, this is one of the biggest pieces. If we were given this equation, and I asked you to graph it, you should be able to look at that equation and say, oh, I know that that's a quadratic. How do we know by looking at this equation that it's a quadratic?
Because the exponent is 2.
Because the exponent is 2. Which means when we make our table and graph this, right, negative b over 2a, we make our table and graph this, what should it look like? A parabola. If it doesn't look like a parabola, you did something wrong. Yes, sir?
How come you share there?
Come talk to me after. Okay, are we okay on that? Those are the only two we're adding for quadratics. exponential is our third one. What did we say last week our exponential graphs look like?
Isn't it like a line that goes before one of the numbers?
I don't have a word for this. I kind of always call it a swoop because I made that up.
Swoop.
I don't know what else to call it. It might have a name. I don't know what it is.
It's a J shape.
Well, you have to be careful because lots of people want to put that in there or put like that Nike sort of. It can't go back up. It's got like. So I'm not even sure if swoop. I don't know. It's that shape.
It's a Nike swoop.
No going back up.
Kinda is like this one.
In the equation, we have an exponent of x. Okay, so if we see an exponent that is x, we know it is exponential. What did we say about word problems, story problems, the growth and decay? Do you remember that one from Friday?
The decays and negative and then
Right, it was that plus or minus, but the big thing that it always happened was with that percent. So if it's a word problem, it changes based on a percent. Right, half of the players was 50%. It appreciates at 2% each year. Okay, and here's why it's important to know that information. So what I'm pulling up here next, trying to pull up here next, is your practice quiz 5. Okay, so we are looking at your practice quiz 5 and going through how to do each problem. Guys, the real world doesn't function in a bucket that says, oh yeah, by the way, when you're earning 3% interest on your bank account, you should know that that's exponential growth, so make sure you're thinking exponential, right? That doesn't happen. You need to go, oh, I know I'm earning 2%. I know that that is then exponential, and therefore that means once I reach a certain point, it's going to start increasing a lot. Okay, you're going to have to be able to recognize that on your own. So when we are looking at practice quiz 5, sorry, this is running like a turtle. Okay, so I'm going to go through like I usually do, and I'm going to give you those steps of how you should start. Okay, so y equals 2x squared. We look at this problem. Okay, so this is number 1 from your quiz. Is this linear, quadratic, or exponential?
quadratic.
How do we know that it's a quadratic? Because it has an exponent of 2. Okay, so this is quadratic. So we know what this graph should look like, and what should this graph end up looking like? A parabola. So somewhere over here we should be getting a parabola. How do we decide when it is given to us in this form what that parabola should look like?
Well, you put the table in.
Okay, so we make a table.
Then you put 1, 2, 3, 4.
No.
0, 1, 2.
No.
Okay.
There's something very specific we have to do when we start a quadratic table. What do we do right here in the middle?
You put a 0 or 1. Something.
We really have to start with negative b over 2a.
Yes.
Now, in this situation, what is b?
2.
No, a is 2,
0.
b is 0, c is 0.
Yield.
So in this case, when we do, right, because this really says y equals 2x squared. So that'd be 2x squared plus 0x plus 0. Okay. So that would be negative 0 over 2 times 2. So 0 over 4 is 0.
And then
So 0.
we go up and down, right? So 0, 1, 2, -1, -2.
Yes. And then you plug it in.
And then we plug each of those values in. So we will say 2 times -2 squared.
Okay.
2 times -1 squared. And we'll just plug in each of those input values.
Those zeros are wrong.
Okay? Does that make sense for that? What doesn't make sense?
You know what? I think I got it.
Are you okay with these input values? So if you type this into your calculator, right, -2 squared is 4, 4 times 2 is 8. How important is it that these end up matching?
You know,
Wait.
Very, right? Because that's that symmetric look that we get. Yes, Bailey?
Wouldn't the 0 equal up to 1 though?
No, because 0 squared is 0. Anything to the 0 power is 1, but this isn't the 0 exponent. Okay, so that's number 1 for your practice quiz. I would be writing these notes down since I'm telling you how to do each of them. Okay, number 2. What type is this? Linear, quadratic, or exponential?
Linear.
Got it.
Quadratic. How do we know that it's quadratic? X squared. So when we go to graph this one is in vertex form.
So we
So this is the one, right, where we can find the vertex of H comma K?
Yup.
Make sure you remember that we always take the opposite sign of H. So you plot that vertex. Is this parabola going to open up or down if A is +1? Up, and if it opens up, we'll then go over 1, up 1,
Yeah.
over 2, up 4.
So H would equal 25. K would equal 2.
Okay? Those are the quadratics that we were really good at. Number 3. Okay, so what type is this if this is our graph?
Negative.
But is it quadratic, linear, exponential?
Quadratic.
It's quadratic. Okay, so in this case it's asking us, like, does it open up or down? Where is the vertex of a parabola?
At the top.
Right, so we'll name that point. Remember, when it asks you to find the equation, you have to put x equals. X equals.
What?
The equation of the axis of symmetry is x equals h. It's this line right here. So it would be x equals 1. Lots of students will just type in 1 and you have to put x equals 1. The axis of symmetry is the line that chops it directly in half.
So you would just go down to the bottom point, or the bottom.
It's always the x value of your vertex,
Oh, okay.
right? Because this is h comma k. Okay. Oh, I can't. I think number 4 is the same, if I remember right. Okay, so number 4 is the same thing. 3 and 4 are the same thing.
Do you think they
I tell it what to put in there. Yeah. Okay, number 5 is graphing a parabola given this form. So what are we going to do if it's in this form? Y equals -3x squared minus 18x minus 21.
That's a, yeah. Okay,
That's quadratic.
This is quadratic. Why is it quadratic?
You put a 0 in
Because that's an x squared. And what number do we put here?
No, negative 3.
It's negative b over 2a.
So negative 8.
So it's positive 18, right? Because the negative of negative 18 over 2 times negative 3.
So negative 6.
18 divided by negative 6 is negative 3 would go here. And then what would we do?
Go up and down.
Negative 4, negative 5, negative 2, negative 1. And if you did the numbers backwards in the table, that's okay too. Six, this is telling you what points to plug in. So you just plug them in and graph it. Make a table, plug it in and graph it. I believe this is now our exponential. Oh, no. This is our word problem. So number 7. If we want to find the minimum/maximum, What is the minimum or maximum of a problem of a quadratic?
1.
Let me ask you it this way. What point is the minimum or maximum on this?
Oh,
What's this called?
The highest.
And what's this point called?
Oh,
The vertex. How do we find the vertex? Mathematically speaking, how do we find the vertex?
I hate. I ain't right now.
Number 7, you should be doing negative b over 2a. The equation is given to you. All you have to do is do negative b over 2a and then plug it back in.
Okay.
Okay? Number 8, it's telling you what values to plug in. Is this linear, quadratic, or exponential?
No,
What's this right here?
exponential.
The exponent is x, so that's exponential. So what does our graph need to look like?
A
swoosh.
A swoop? Okay, so you plot the points and then click it and it will put the rest in there. Here you're just plugging them in and completing the table. Right, so you put in your calculator 9, up caret negative 2, 9, up caret negative 1. And this one's just like number 8.
Okay.
Right? It's exponential, you're making the table, you should be getting a swoop. Alright? So here's what we need to be doing first.